Computer. Perfect. Great. So hi guys, Karibuni. Welcome to today's meetup, and hope you guys are really excited about this specifically. Just about S3. It's one of my maybe go-to AWS solution, especially for object storage and stuff like that. So I'm really excited to have this, and also just to dig into storage as a topic as Brian takes us through this. So it's a complete guide to S3 logging, observability strategies today. And we are having Brian Kefa here today. Brian is an enterprise cloud storage engineer. He's a tweep on Twitter, and also he's really, really like passionate about Linux and storage in general, especially enterprise storage, and he's really good at it. So really excited to have Brian here today. This is our second meetup with Brian. I think the other one was really successful. It was a deep dive. I loved it. So Brian, without further ado, really excited to have you here today. Yeah. So get away, Brian. If you can hear me. You can hear me.
Loud and clear, yes.
Yeah. Hi, Brian.
Hello.
Hi.
Let me share my screen. Right. You can see me?
Yeah, we can see you. Hi.
Perfect. All right. Perfect. Let me share my screen.
How's your week been as you share your screen and kind of get into it?
Pretty chill, pretty good, pretty good.
Mhm.
I take stuff one at a time. So
Okay.
yeah, I make sure every time I wake up, I'm having a good day.
Yeah. I don't know if you're an Arsenal fan or you're not into football at all.
No, I'm
No.
not an Arsenal fan.
Uh-huh.
Not like super big fan of football, but I do follow. My family is Manchester, so yeah,
Oh, okay. So they hate
yeah,
to watch the
Manchester.
other game. Yeah, I'm big on
Yeah,
basketball,
pretty much,
but yeah.
yes.
All right. Take it away.
Yeah.
Thank you.
All right. Thank you, Mark. Um, everybody here. Let me look at. Do I know anyone here? I think I know Michael Owen. Well, it's Joel. Okay, so my name is Brian Kefa. As Macorina said, I'm an enterprise cloud storage engineer. Yeah? So people usually ask me what exactly that is because you don't see a lot of those. Yeah? I think I started off as a cloud engineer and then I started handling specialty in storage. And I think it's a really niche place that most of you should probably think about getting into because it's super nice because mostly storage is low level. Yeah. So most of it is actually low level stuff. So you need to know stuff about how Linux work, kernel. If you most of the things that we do on storage is about tuning performance, right? Because we want to get the maximum performance we can out of every little thing we have. So today I just wanted to talk about S3 because this is a service of which I am a subject matter expert in, and it's one that I really love. If you talk to anybody who knows me, they will tell you that S3 is my baby. Yeah. So if you need anything help, anything regarding S3, you can reach out. Now I'm still a storage engineer, so it means I go across the entire stack. So that is basically object storage is S3, obviously. We have anything that is a file system. So whether it's become Elastic file system, we have Lastia for high performance. So people who are doing things like how do you call it? Um, Companies, enterprise companies that do things like molecular research, such as Eli Lilly and Co. So they use that a lot, including Instagram. Instagram use a lot of Lastia for to serve your specific content on Reels and stuff like that, and then obviously block storage. So today we're going to talk about specifically S3 because S3 has come a long way. S3 is basically usually very primitive and it's object and flat storage, but over the course of time it has evolved into something else. So we have it was object storage. Now we've evolved it into what we call vectors. We also have S3 tables, and now we have S3 as a file system. Even though we spent a whole lot of the last 20 years saying S3 is not a file system, and if you use it as a file system, you might wake up in the morning and find you have your bill has escalated to whatever. But looks like people wanted it as a file system, so they figured out let's make it a file system technically. Right. So I'll just start. So now, unlike everybody else, if you've ever been to any of my, or I call it classes or lectures, I'm not very good with PowerPoints. I don't know how to make them. I just prefer let's just get into it and just do and implement stuff like that. So the reason we need to we're talking about S3. So we want to log S3 the entirety of it, know what exactly we are looking at, because it might be simple. You're working as as a passion project for your S3, which is okay, nothing big. But when it gets to a point when it gets to enterprise, you need to know every single detail, what comes in, what goes out. You need to, for things like cost analysis and stuff like that. So we're going to, I already set up others because I want to show you stuff, how it works. So we will set up a few of them now, but I already set up others, including things like how we can query our access logs and stuff like that. So when it comes to logging, we do usually approach it from two ways. So you log things from server side, or you log it from client side logging. So client side logging meaning, for example, in this case, if you're going to use anything like CloudTrail, or we're going to use anything like server access logs, we log it from the server end. Then we also have client side logging, which most people don't do. Because obviously there's some performance trade-offs that you get when you're logging things client-side. Yeah, for example, if your application is client-side, then you're sending back logs, basically probably using your client, let's say a Java S3 client. Depending on what you're logging, you might have to trade performance, because doing logs back and forth might do that. So we're going to do that. So first thing, we're going to talk through. We're going to talk about server access logging on S3. We're going to talk about CloudTrail. We're going to figure out which one is good for your specific use case, because there are trade-offs for why you would need to use server access logs and CloudTrail. And we also have things like storage lengths, which I figured a lot of people, over the course of working with enterprise clients, people don't know how powerful storage lengths actually is. Then we're also going to talk about how do you specifically log client side, because sometimes you get into specific errors. Like, for example, if you have your client running to S3, and then something happens where you're getting things like TCP reset or timeout connections, you can't log those server side because the issue comes from client. So you'd rather set up logging on your client side. So let's start with simple stuff like I have a bit. This is basically a bucket. Let me zoom in. I think somebody confirm me you can actually see this. You guys just confirm. Perfect. Thank you. So this is properties. So one thing, let's start with server side. So most of the time, you probably do not need any other logging apart from server access logs on S3. Server access log, basically, it logs everything that happens within your specific buckets, including failed authentication attempts, for example. So setting up this is pretty much easy. Now I'm going to walk you through doing it on the console, but obviously we know that once you know how to use it here, everything else is usually automated. So you can write it using either CloudFormation, or you can set it up using CDK or whatever. If you're somebody who likes to, who basically likes to interact with the AWS using SDKs, that is something you can do. So if you go into this specific part, there is one called server access logging. Yeah, so this is server access logging. So enabling it is actually pretty simple, where you just come here and say enable. And then once you enable server access logs, you need to assign it another bucket where all those logs are going to sit in. So you log this bucket, you need to have a destination bucket where your logs are going to sit in. Now, two things that I want to talk about is the two specific points here, which we have what you call log formats. So there is the first one and the second one, which most people will not be able to understand. So the default logging format here, most people use it. And then we have one called speeding up analytics, the second one. So I want to show you what they both mean. So this I already set it up earlier. So let me show you what those two things mean. So if you check where I logged this, so this is in storage cost. So S3 Central. So I have a bucket here called Central Prod Access Logs, this specifically. So I have two logs. So this is storage code. This is the bucket I just logged. If you look at this specific, if you look at what we have here, for example, you can see that all the logs from that specific bucket are sitting in one plain file system. So they're all here. It's just sitting here. It might not make sense, but for example, if I'm generating, let's say, I'm in an enterprise environment and I'm logging, I'm running basically 100,000. So I'm hitting S3 at about maybe, let's say, 10,000 transactions per second. So it means I should be generating that amount of logs per second. Now, the problem happens in this particular case it's a month or maybe 2-3 months, and then you want to specifically come and query. You want to start querying objects. For example, you want to say, last month I want to find this specific request that came at this specific amount of time. You're going to open something. You're going to open Athena. Athena is a query engine that is actually, so it's one of those services that once you know how to use it, it's going to make your life really, really simple. Yeah. So when you come to Athena, one of the things about Athena is you set up your logging, you set up a database on Athena, and then you set up a table, and then that table format so that when you log your objects to S3, you can basically query them. You can actually query them easily using simple SQL. SQL is something everybody understands. Yeah. So if you can basically query things using simple SQL, that's okay. So now the problem is if you set up the first format here, which is this, you're going to end up with your log sitting in this one file. An analogy would be like you go to a school and then you want to find somebody. You want to find a student out of, let's say, 1,000 kids, and then they all come and stand there, and then you're looking for one single person. It doesn't make sense. It's not efficient. A better way would be you go to that school, tell everybody to sit in their own class. Then you say, for example, you're looking for a specific student. You ask which class are they? Let's say they're in 5th grade or Form 1. So you go to Form 1. You don't have to go through Form 3, 4, and Form 3, 4, and 2. So you simply go to Form 1, and then in Form 1 you look for which stream. Then you pick that stream. It's a much more efficient way than having to cycle through Form 1, 2, 3 when they're in one place together. So this is a bad way of doing things. It's going to cost you a lot of compute and runtime. And because Athena might time out, and because Athena also charges you basically based on how much data you're actually querying through. So if all these logs are basically 10 gigabytes, then you're finding a specific object, you're going to query through 10 gigabytes worth of data. Now, in retrospect, if you decide to use this speed analytics, it brings you some type of it's going to come out like this. So it's going to come out. So you look at this. If you use that, it's going to come in, gives you USDist1, then it's going to take you to this specific bucket. And then it's arranged in terms of 2026. So you're in 2026, and then this is February, March, April, May, June. So you go specifically to months. So when you're trying to run your query, this is how your query engine is going to do. So you're trying to find an object that is in March. It's going to come here and say it's 2026. It's specifically, let's say, this is June. I'm not sure if it's June. And then what date? So if it's on 4th, it's going to open 4th, and then it's going to only query data on that specific day rather than querying everything. So that is one thing you also need to figure out. So always, every time you're setting up your engine, always make sure you're setting up this for quick analytics. So you basically only query what you need to query instead of querying everything. And if you have more 10 GB or worse, you're probably going to run your query engine and it's going to time out. So it's probably a bad example. So this is what you did. So I set it up here the first time so that you learn how that works. I also have one. So let me get back to this. So I have a general purpose packet. So I have this. This was set up. So if you go to these properties, I specifically set this up. Bucket versioning, sorry, it's properties. Server access logs, yes. So if you do this was set up using this query analytics engine. So now when I set it up using query analytics, I will go to Athena editor. So on Athena, you pick catalog, and then I go to specifically. So I look for which database. So you need to set up your specific database. Yeah. So you need to set up a database because if you look at AWS server access logs. So this is where every time you listen, everything is in the documentation. So AWS S3 server access logs, server access logs. So logging, and then we have a logging format. So we have log format. So these are all the log format. These are all the log fields that we have when you send requests to server access log. Now you want to basically query them. So you basically create a database, and then you create a table that matches these. so that you can map them to Athena so that you can query them. So once you do this, let's use our second table, the one that we created. So let's use the second table, this specific one, because I didn't set it up. I didn't set up Athena on that. So I come to properties, which is specifically this. So how do I make that? So I come to Athena. Perfect. So I have a database. So this is database. So I have a default database, and then I have S3 access logs DB. Yeah. So now I want to create specifically a table. So this is specifically a table. Let me create a different database. Let me create a different database. Let me create a different database just so you can figure out how that works. So, so everything, like I said, everything exists. Everything exists on documentation. So I come here. It's simple. So in this particular case, create. So create create Athena database. Server access logs. DB Athena. Identify request. Perfect. So this is, I'm going to create a database. So simply come here and copy this, and then come in here and paste this. So I'm going to call it server access log DB2. So I'm going to call it DB1, this particular case. So I run that, and then you run it on Athena. It's going to create a database successfully. So if you come here and run, I can simply set on my database DB. So I've set it up to my other database. Now, the second thing is you need to create a table that maps to those specific fields for what you're going to deliver to the logs, which is very simple. It sits here. So we sit here. So this is what we have. You simply come and copy this. Now, different check. So we have two different one setup. So there's the date-based partition, date-based partitioning. This is the one that I said it's recommended for you because you want to basically map your data based on date so that you don't have to query your entire objects that you've basically sent. So this is the first one. Now, because I set this second one to non-date-based partitioning, I'm going to copy this. So I'm going to come here and say, copy that log, and then I'm simply going to run that query here. Okay, so create external buckets, DB log, and then it gives me all queries. So these are all the fields that come with server access logs. So I have bucket owner, bucket name, request date, operation string, and all that stuff. So the only thing that I need to change here is what is the location of what is the location of where my logs are. So that's why I come here to this specifically properties, and then where are the properties? So this is the central prod logging. So I go to my properties and perfect. And then I come here to storage go. And this is it. This is all I have. So all I need to do is basically copy that URL, and then I sit here, and then I'm going to change that URL here. I'm going to copy that URL in between here to say that, okay, if you're going to create a table, how are we going to fill that table? We're going to fill it with the data that exists in this specific path. Then I'm going to run that. I'm going to simply run that. Failed. Already exception. Table bucket log exists. So from approach, the query done against S3 DB1 unless qualified for the query, please. Let me see. Let me see. So this is bucket table. So let me see logs. Maybe so S3 access logs DB underscore one. Let's do underscore one and then run that again. Sorry about that. So we are good. So now we've created our bucket. So once here, we come here, and then we've created my logs. So let's refresh that. So now we have created our table inside our database, which in this particular case was access log DB1, right? So let's three access log. So create external table, so log DB1, and then, so now that we have this, we're going to simply do a simple run query where we're going to sit here, and then we say, let's preview our table in this particular case. So here we come, we see, so now we can preview our table. So from here, we can see, so we can actually preview our table where it gives us what we see here. We say, we can see bucket owner, bucket name, request date and time when those requests were made, gives you the remote IP from when those requests came in and who made the request. So the requester usually is the ARN of the specific caller of that specific request. It gives you the request ID. These are you use this specifically, especially if you have issues and you need help from, let's say, AWS support, because these request ID are very, very unique. So when you make any request to an S3 endpoint or any S3 endpoint, you generate a unique request ID. Usually the request ID pair. So there's the first request ID and then the XMZ ID2, which I'm going to show you. So this is generated as a response for every request that you come up with, which if you give it to AWS support, they are supposed to be able to map everything. You'll find out information about the request. Then these operations. So we have REST operations. So as we speak right now, S3 only does REST operations. SOAP was basically deprecated, I think, back in 2025. So if you try to send a SOAP request to S3, you're probably going to get an error. So and then we have the request URI, basically tells you, so it's a put request in this particular case, and you can see it using HTTP 1.1. And then we have HTTP status. So for 3-200, basically you can tell. So for specific requests, what happened? You can see that request was basically a 4.3, and the error code is basically invalid access key ID. And then byte sent. So I'm going to show you how all these specific data should come and work for you. And then you can look at specifically the client that was used to make that specific request. So like right now, you look at user agent, it tells you that I used AWS SDK for Java version 2 to make this request to specifically S3. And then if somebody used a browser, you can see that this is Mozilla Firefox that was actually made to that specific. Then we have specific things like host ID. So this is the request ID XMZ ID2, which most of the time you do not need. And then also things like signature. So right now, S3 only accepts signature version 4. Signature version 2 was basically deprecated. So you might be able to use this to troubleshoot issues. For example, if you get something like the specific errors that you get on S3 signature mismatch. So those you can basically look from here. For example, if your client was a legacy client that was basically still interacting with your bucket, basically based on signature version 2. And then there are specific things called auth type, which you have two types of auth type, which is either use auth header or query parameters. The way that you know if a request was made using a specifically credential, or if somebody made a request, let's say, for example, you guys know about, there is this specific thing we talk about, how do you call it? Pre-signed URLs. So if you pre-sign your URL, the way that you know that a request was done through pre-signed URLs is if the auth type is query parameters, that means you're basically using pre-signed URLs. And then, of course, obviously, if you want to check specifically TLS handshake that was done at the point that was made, this is how you specifically log your requests. Yeah. So let's come back here. So this is basically me basically walking you through how to set this up on basically Athena. So like I said, Athena is actually a very powerful query engine to help you do this. So this was basically to help you set up stuff. So let's go back to the table that we already set up. So the original table that we basically set it up to have to basically optimize query analytics, which is this specific one. So we are on basically TB, and then we're here. So you can see this says that we have partitioned it based on query date and time, right? So I can simply preview that table as well. And then obviously you can see this is what we get. Now, so let's do a few queries and a few things that you might probably need to specifically answer. Yeah. So this is when it comes to this particular case, it's all about like how much SQL can you write. Obviously, SQL is a high level. It's very high level. It's one of the reasons we have things like open table formats, because earlier in the days when people wanted to do queries, they needed to run MapReduce jobs, which was very few people. It's not an efficient way of doing things, writing queries and stuff. So people needed to do MapReduce jobs. But when we came with open table formats, you can basically you don't need to know what is going on down. So you might have S3 HDFS. But the open table format basically exposes that so that you can basically do your analytics using specifically MySQL. So you can plug in any engine that you want, whether it's Apache Spark or whatever. client that you have, which is pretty much okay. So in this particular case, let's do a simple query. For example, to this specific bucket. So right now we are querying this specific bucket, which is not this. We're going to query this specific bucket. So this is this is the one that we are going to query. So you're going to see me. I have a lot of 3-character hash things that I have going on. You will later basically come to realize the reason why I have this specific 3-character hash is for issues with performance. There is how S3, which is a flat storage, actually works that you need to understand. Or I probably did this in a previous version when we were talking about how to optimize S3 performance, where we talked about S3 being flat. So for example, I'm going to talk about S3. So S3 is a flat object. So we talked about, if you look at here, for example, we talk about S3 performance. We know that S3, the client, the S3 front end can basically do specific maximum. So for any put object, put, post, and copy delete objects, you get 3,500. 3,500 transactions per second, and 5,500 get head requests per second specifically for each prefix, right? So the way that you maximize this is if you are able to design your S3, if you're able to design your specific buckets so that your client basically writes objects to S3, and then it parallelizes those requests across a specific paths, so that when you hit, for example, in this particular case, so if you don't, basically, for example, if you don't parallelize your request from your client and then have them hit a specific path, then once you hit, let's say, 3,500 transactions per second, you're going to start to bottleneck. S3 is going to slow down, and then it's going to send you a 503 request to tell you to slow down while it tries to, to basically to partition itself in the backend. You need to do that consistently for about maybe an hour for it to work. So you need to design your S3 early enough so that it scales by itself in the near future. You need to make it scalable. But we're not here to talk about S3 performance. We are specifically here to talk about this. So for example, let's look for a sample query that I want to do. So this is an object. So let's break it down. So select everything from S3, which is basically my table. So this is the database. This is my table. So let's remove a limit. Okay. And then we say where. For example, here, let's say where. So you look at this. So for example, I want to find out who did what. So where, for example, let's say, for example, we want to do operation. So in this case, operation, we want to find all the operations, where operations equals. So operation is equals to here. So rest. So these are REST objects. So if you look at, for example, if you look at operation here, this is what you look at. So if you look at operation, the basically REST request. So you want to look at all operations that involved rest.put.object. So in this, I want to look for rest.put.object, right? So select from that where REST. So we can start from there simply. So you're looking for all put requests, rest.put objects. So we're getting 1995, right? Pretty much okay. And then in this particular case, let's talk about REST. So it's put request, and I can say and. What else? Let's talk about in this particular case. Let's talk about auth type. So we want to look at auth type. So we want to look at auth type, and then if you look at auth type, you want to look for one that has query parameters. So we want to look for any request that was done using put request that basically was pre-signed. So you can come here to, for example, log formats for, if you want to look at server access logs, let's talk about server access logs. So server access log format. So the earlier you learn how to use the documentation, the easier it's going to come. So if you come here to, for example, auth type, auth type, type. Right, sorry. This is log format, so let's look at auth type. So operation request, talk about auth type. Okay, authentication type. So this is authentication type. So you have auth header. So auth header. So we have specifically. So example entry is either basically auth entry or query params. So query parameters. So let's look at that. So auth type. Let me look at this. Entry type. So authentication type. Where is that? Okay. Authentication type. Authentication types. So right. So authentication type. So for authentication, so query string. So we have a query string and then we have an auth header. So let's look at that. So simply come and pick this and come and set it here. So do that query string and then you run that on S3 objects. So it's going to, let's pick it up. So out of all that, out of all the requests that we had, these 97 specific requests that are put object requests that were returned or basically these were pre-signed. So it means that this request were pre-signed before they were sent. If you have no idea what pre-signing means, I'm going to talk about it a little bit. So you can see. So the way that you know an object is pre-signed is you can look at its request URI. So you see, when you talk about pre-signing, you can look at the URL and it can tell you everything. So you can look at the entire URL. It's usually this long because it contains number one. It contains, so it's a put query parameters, and then you can see we have the ASIA, which is basically that is the access key. You can see we have the signature and then XMZ security tokens. It runs here. So it can tell you that these requests were actually pre-signed before they were sent. And you can see they came from Python. I believe I was testing this on Python Boto 3 SDK and query string. So this basically tells you that these were pre-signed before they come in. So if you don't know about what pre-signing is, let's do a little bit of what pre-signing is. So every time, the way that S3 works is when I want to send a request to S3, S3 has to enforce and make sure that at any point, the request that I sent is actually a legitimate request. So what does it do? So I take a request to S3. I make a request to S3. Let me open documentation for you. So S3 is going to take everything that it needs to send this request, and then it's going to sign it. Yeah, it's going to take this request and then it's going to sign it, and then it's going to attach a specific signature before it sends that specific request. And then once that request is once you send that request over the wire and then it hits an S3 endpoint, what does S3 do? S3 basically strips those parts that basically make up S3, make up that request, and then it calculates its own signature as well. Right? So S3 is going to strip that, calculate its own signature, and then it's going to compare the signature that S3 calculated to the signature that your client did. So when your client is sending a request, it's creating its own signature, and then it sends that to S3. S3 strips that, creates its own signature as well, and then compares those two signatures. So if those two signatures match, S3 will happily accept your request. If it doesn't, you're going to get the classic signature mismatch error. Right? So specifically, so if you look at something like signing, S3 signing, S3 signing. So authenticating request using signature. So there are two types of which we basically do authentication. So we use authorization header, which most of us do, meaning we get credentials. We get credentials from S3 here specifically. So there's a lot going on with S3, for example, components. So we take our credential, which also every time a request is sent to S3, it's restricted to a specific region. And we have signed headers and all the signatures. So a signature is attached. Then when it's sent, it strips out all these, calculates its own signature, and then compares them and say if they're good, that means. So the reason why is obviously you want to do protection. You want to make sure that this request was not terminated. It was not tampered with or when it was going over the wire and stuff like that. So those are things that you can actually use to do. Another thing is, for example, stuff like that, you want to check, am I getting any performance bottleneck within S3? So if I'm going to do rest.put.object, for example, and auth type is query string, we can remove that and say, for example, and HTTP status. So status. So we said every time S3 gets overwhelmed, the S3 fleet gets overwhelmed by request, it throws you a 503. It throws a 503. 503. right? So the reason S3 does throw a 503 error to you is because S3 is flat object storage, and it is built to make sure S3 is built with 11 nines of durability, and it's supposed to be reliable. Now, I talked about the fact that, for example, I'm going to just mention it a little bit. If I create an object right now, for example, let me create a bucket, for example. So when I come here and create one bucket, let's say AWS user group, Kenya. Kenya. Let's see if that is already taken. So we're just going to create one bucket. Nobody has created that bucket already. That's ridiculous. Okay. So if I create a bucket right now on S3, what happens is S3 takes this bucket and puts it in a pool somewhere. So it's sitting in a pool somewhere with the rest of other people, right? It sits there with a pool with everybody else. Yeah. So once it sits in that specific pool, it's sharing resources with all other buckets that probably starts with A or W and S. So when you start sending requests to this specific S3, and then you start overwhelming with too much request, S3 needs to make sure that all customers that are being served by S3 should not be interfered with. You don't want, for example, you're in a rented apartment, and then mtu anakuja huko, and then somebody decides they want to start making noise. That is not okay. You need to guarantee that your customers are going to enjoy the ambience of your state. So if somebody tries to make noise, you're like, okay, we are giving you a warning. So one of the things that S3 does, that is it. So you might find there's 1,000 buckets that are sharing same resource, because S3 fundamentally at the backend, it's basically storage, basically networking, it's basically power, it's basically hard drives, right? So when it gets to a point when you start hitting these specific limits, if S3 doesn't throw you 503s, it means you're sitting in the same, you're basically using the same resources. Other people might get bottlenecked. So for example, somebody is basically sending 10 or 15 transactions per second through S3 front-end fleet, yet they're starting to get throttled. Why? Because you have noisy neighbor, some sort of noisy neighbor. So your neighbor is taking resources that are yours. So you don't want that. So S3 sits there, we create this specific bucket, and then once you start scaling up, S3 figures, okay, you're too big for this. So S3 will take you out, it will start to scale, and then put you on a dedicated resource. So it gives you your own networking power, your own hard drives, so that you do whatever needs to be done. That's basically what S3 does. So you want to probably check, in this case you want to check, okay, we're looking for anything. You want to track and see if S3 is actually generating this specific kind of errors. Now, most of the time you will get this. This is you trying to dig deep, because if you're going to be getting, for example, that kind of errors, it's going to show up on this. So for example, if you look at let's look at this. So you need to set up when you set up metrics. So S3 has its own metrics. So by default, you get bucket metrics, which basically tells you how many objects you have on S3 and what is the total bucket size for S3. So right now we have 167 million megabytes, and then this is the number of objects. Then if you look at additional charts, you need to set up what you call request metrics for S3. Request metrics actually charged extra, so you also need to know when you're setting that up. So if I come to request metrics and then I filter this, it will give you a whole load of things. So it tells you all the requests: get request, your put request, your delete request, your head request, post request, all of these. Now, so before you even go to track this, you should come here to look at 5xx errors. Basically gives you 500, 5xs are 500, and 503 errors. So 500, usually it's some really big server errors. So 500 can manifest as 503, 503s can manifest as 500s. No big deal. 400 errors, for example, you realize, okay, you're getting a lot of authentication error. 400 errors are basically authentication. In this particular case, for 3, you're not authenticating well. Yeah. Fast byte latency. Sometimes you realize, okay, things start to get slow. For example, yeah. Sometimes it's not even your issue. Sometimes S3, the service is probably having downtime. Yeah. So these are the things that you go. So for example, you come in and realize, okay, I'm getting a lot of 503s. You want to figure out, when you're getting 503s, what is the issue? So you probably want to look at, where is this 503 coming from? So you come in here and then go into your query mode, and then say operation is put object. You can do 503s come from anything, get. So let's start with, let's say, put objects. Then I run for puts in this particular case. So it comes back with, I have 393 requests that basically returned 503 errors. So in this particular case, we're going to come back to request ID. So you can see the keys. The keys come from this o6k test.packet, this o6 test.packet file. Those are packet files, right? And then we also have query params concurrent.pin, right? So you see that. So we can simply go and look at and figure out what exactly was happening inside that specific bucket. So if I go to the bucket, so this is, let's look at the bucket. The bucket name is H3 product name, this H3 prod US. So I can simply come here, and then it is O6K, which is here, I believe, and then it is OUV, right? Perfect. And you can see test.parquet file. Let me show versions and then do that. So, right. Now, one of the things I see, let me look at this. So let me look at that. So request date time. Let me look at yeah, so request URI. So you can see a lot of it's a specifically one object. And I think I know what is happening here because I was basically doing testing. So I was basically trying to simulate what we call S3 concurrent request, where I'm basically uploading 10 objects within millisecond latency of each other, because S3 introduced something we call the read after write consistency. Yeah, where immediately you do a put object, you can actually read that object and it's consistent enough. So when I was running that, I think this is what was getting 503 errors, right? So I was generating 503, which is one thing I also want to tell you, that most of the time we talk about 503 as, 503s are generated by S3 because you're hitting those specific limits for S3, for example, 3500 or 5500, which is, those are true, except also if you do things like concurrent. So when you're sending concurrent requests, that can also basically throw 503 errors for you, because you're basically, if you're modifying a specific, you're basically doing concurrent puts on a single key, because you can see this is the same key as 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 the same key. It's the same. So I was basically sending a request, same key, 10 times, and then I think I ran this like 5 times, and then it's generated 503 errors. So those are a few things that sometimes you can use to test to see, oh, okay, this works, this doesn't work or not. So you can see, it tells you that this is where the issue is. So if it was some sort of enterprise, you can go to AWS and say, yo, I'm getting a problem here. And you can talk about or with your internal solutions architect and think about, let's talk about how are we going to scale this design so that we don't start getting all this. Yeah, for example. So usually for things like concurrent puts to the same key, usually it's more of a like, why do you need to be doing concurrent puts to a specific key? Most of the time, it's just better for you to go and redesign so that your client doesn't do that. If you have a specific reason why you have to reach out to AWS so that they do their magic internally to fix that for you. If you have a business use case, a big enough use case for why you need to be doing that concurrent puts to request key. Yeah. So that's why some people, those are things that usually happen. Edge cases where you come in and somebody's like, hey, I'm simply doing my client is doing 25 puts per second to S3 and I'm getting 503 errors. They're like, why? Yeah. So such things. If you're doing concurrent puts, that will generate. Or for example, this other thing that I talked about, if you're doing a noisy neighbor, you are sharing the same thing. So those are things that you can generate and then you look at. So look at specific clients and stuff like that. So let me see. Look at this. So signature version 4. Others might just be AWS requests. Others might just be AWS issues, because AWS obviously, as any other system, or S3. Let's talk about S3. S3, any other system might have issues coming down and things like that. So in those specific case, you basically send AWS this request ID. This request ID is enough for them to actually figure out why exactly are you getting issues like that. Things like this. You can also use these things to calculate things like latency issues, for example. Yeah, so latency. Yeah, so obviously you look at timestamp, and then you can also calculate latency issues. Sometimes, how do you calculate latency? You can use things like turnaround time, total time, and object size, so that you look at, okay, in my normal cycle when I'm doing put requests of this specific amount of objects, this object size, this is the approximate turnaround time that I'm getting. But right now, what I'm getting right now isn't making sense. So you can use those to try and figure out, okay, where am I getting performance bottleneck? Is this an issue from my end, or is this an issue from AWS? So these, like I said, these are basically server side. So these are basically, we are doing server side queries in this particular case. And things like, for example, string partitioned. Let me see total time, request URI, HTTP status, request ID, specific key, and operation. So you can see this is how that works. Yeah. So like I said, server access logs also work. They will give requests, failed requests, so authenticated requests. So if you try to authenticate, for example, one of you, I mean, I should have said it earlier, but if one of you had tried to, for example, make request. So if you try to make a request, if somebody can try to make a request to this specific bucket. You can try to make a request to this bucket, which is basically this. You can basically try to make a request to this bucket from wherever you are. Copy. Somebody can try that. You can try to make a request. You can try to do AWS S3LS. So just go to your, you can test and try to make AWS S3LS, and this specific bucket. So for example, in this particular case, properties, and you just AWS S3. So talk about and then you talk about S3 dash, and then you paste that here. So if you run that from your end, obviously it's okay. I didn't have my token set up, so I can just do. So obviously it's basically failed. So it's told me list version 2 has expired. So this is an unauthenticated request. It's going to show up as a 4.3. Now, note, one of the reasons that people people asking questions. I didn't know that. I didn't know that. Okay, I didn't know that. Okay, people are actually talking. You guys check the comment section so that at least I don't pass. So right now this request is authenticated. So now one of the things, let's talk about advantages of why you need to use server access logs. Number one, server access logs are cheap. They're cheap. So it means the only thing you specifically pay for is storing them. So you don't pay for basically the requests S3 serves as requests. You pay for a lot of things in terms of S3, but in terms of server access log, all you do pay for are, if you're storing 35 gigabytes, that is what you're going to pay for. So they're very cheap. So that is why you'd opt for. So I would say most people should opt for using server access logs. That is one of the advantages of actually using it, right? One of the reasons why you'd not use server access logs. Number one, server access logs, it will tell you that server access, they're not consistent. So if you look at one of the things about server access log, it says that they deliver logs on best effort basis. So you're not sure that you're actually going to get all the logs. Note that, yeah? So it's on a best effort basis. Number one, you don't know when the logs are going to be delivered. So like right now, I basically made that an authenticated request. That log might come after 3 minutes. It might come after an hour, might come after 3 hours. We do not have an SLA for when those logs will actually make it to your bucket, right? So it means if you're somebody who wants to do logging, for example, you're running a test right now, you want to figure out what is running right now, then server access logs are not going to work for you, because server access logs are best effort basis. There is no SLA for whether they even get delivered even in the first place. So they just basically they're a general view of what is happening into your bucket, and they do not have a timeline. Yeah, so that is the first thing about server access logs. Now, another advantage of server access log is they also log unauthenticated. They log as long as anything tried to make a request to your bucket. Server access log are going to show it. Yeah, they're going to show it, which is different from something like CloudTrail. We're going to look at CloudTrail in this particular case. Yeah. So right now, server access log, and then server access logs are only set per bucket. So you set this bucket, log it, and then send it to another bucket. Log it, and then send it to other bucket. So for example, this is a log. I have sent this log. I've sent the logs from this to this other bucket. Let's see this other bucket, for example. Let's look at prod. So I've sent this to central prod access logs. So they're sent here. Now, one thing also, you should never, don't ever fall into this trap. This is a logging bucket. So never log a logging bucket. Do you get what I mean? You should never log a bucket that is a destination for logs. So for example, me logging this. So if I decided to come here, properties, and say, I'm logging this bucket. That is a disaster. That is how costs spike up. Because if I decide to log this login bucket, get it? This is the login bucket, and then I decide to log it. Do you know what happens when you log a logging bucket? Yeah. So the logs, so I have these buckets that I've logged. Then the logs are coming into this log bucket, right? Okay. So when they come into this specific log bucket, what happens to the log bucket? The log bucket gets logged. So more of like you're going to have some sort of circular dependency where your costs are going to spiral because the logger is getting logged, who is logging the logger or whatever stuff like that. Yeah. So always make sure, always the destination bucket, don't log the destination bucket. Don't ever log the destination bucket for logs. That is one thing. Now this was basically server access logs. We have already talked about how you can use server access log and a few of the things that you should probably note out of that. Now the next is, let's talk about we're still doing server side logging. The next one is, let's go to specifically CloudTrail. Most of you are aware of CloudTrail. CloudTrail is basically central logging dependencies. Now, one thing you need to know about S3 APIs is that there are two types, maybe three more. You know, S3 is the one. It's the one service that you wake up and they introduced everything. So if you look at S3 API, S3 API reference, API reference. If you look at the S3 API reference here, we have Amazon S3 API operations. We have this specific one. So let's look at actions. So we have bucket operations. So when I create a bucket, those are logged. So for example, if I come here to this S3 and then I come to event history, right? Event history, for example. So I simply look at, for example, an event name, the name of an event, which is create bucket. So create a bucket. So I created a bucket, right? So if you look at this, you can see it basically did log. Let me zoom that. It logged that I created the bucket on June 6th. This is my username, S3, and then this is the name of the bucket. So also note that CloudTrail stores your data for the 90 days, and then it basically dumps them. So you should know that. So S3 CloudTrail only logs what you call management events. So things that happen at bucket level, those are the only things that S3 data management event logs. So if I create a bucket, it will log it. If I basically delete the bucket, obviously it's going to log it. If I do something like changing, or for example, I come into management and I decide that I want to do Lifecycle, S3 will log that. So anything that you're doing at bucket level will be logged by S3, by CloudTrail. CloudTrail will log anything bucket level. Now, most of the time we don't do a lot of bucket level stuff, for example. Yeah, don't do bucket level. You create a bucket and then you go into, you configure permissions and all the properties, and then everything else from S3 is you're doing gets, puts, deletes. Those are not logged. So if you go into CloudTrail and then try to do trying to do abort, for example, put object. So put object. You don't. Everything is bucket. So bucket level APIs are not logged on S3, and that is the one thing that most people actually want to track. Somebody wants to track who uploaded this specific object. Yeah. So that is the one advantage. So this by default does not do data events. So those specific events like put object, delete object, modify an object, head operations, those are basically data events. So CloudTrail does not do those by default. So if you want to track those, you actually have to do them by yourself. So you have to come here to something like a trail, then you have to create a trail. Now, one of the advantages of a CloudTrail of let's say server access log is that you can create a trail for every single bucket in your entire account, right? So you can create a trail. So I come here and say I create a trail. Then I want to talk about S3 data events. So S3 data events, right? So all the events that I want to do that. Now, I can decide to create a new bucket where I'm going to set up all those. So enter a new bucket name and folder prefix to store your logs. You can decide that, or use an existing bucket that you already created to put all your buckets. And then obviously you'd want to decide the keys. So everything S3 basically enforced right now. Any bucket that is created, every bucket that's created is by default encrypted by SSC server-side S3 keys, SSC S3. You can override that with any KMS, either AWS managed KMS key or your own KMS key. You can even bring in your own key material to basically use to encrypt all your data objects. So I can come here, so I can use a new managed key, or I pick an existing AMS key. So I don't want to do customer managed key. So let me see, log file SSC KMS. I don't want to do anything SSC KMS, because when you come to KMS, we're going to have to need to do specific KMS permissions and stuff like that. So let's leave that. And then you can also send this to CloudWatch logs. Yeah, you can also enable this. That is one of the good things about CloudTrail. I can send this to CloudWatch logs, then I can use CloudWatch Insights to do this stuff. So I can come to CloudWatch logs, and then I have a policy document here. So if I enable that, obviously it's going to add specific permissions so that, or to allow CloudWatch to actually access those specific objects. So now, where am I? So I've created this specific one, and then I enter tags. So I also usually like to have tags for every resource that you create. Now, the second thing is you have to choose data events in this particular case. So you want to do both management and data events in this particular case. Why? So you enable data events. Then when you come here, you're like, okay, we want to do read and write, obviously. And then from here, you can choose so advanced selectors. So resource type, you're going to choose which events that do you want. In this particular case, we want S3. So we want S3 object events. Then we log only read all. We want to log these, or you can do a custom event. I don't want that. So we want to do log all events. Change selector template. So I'm going to log all events. And then let's look at JSON view. That's not going to have, going to add that. And then one of the things, like I said, you can switch to basic. If you go back to basic, your current work will be lost. Okay. So now this is the specific part where you can decide. So if you, by default, if you do S3 data events, you will log all the buckets in S3. If you want to log a single, log a single bucket, then you can browse. You can basically add a data event type. So this is a data event type. So S3 in this particular case, bucket prefix. So all current and future buckets, read write. So all current and future buckets. So read write individual, and then is that selector. So this is S3 selector DynamoDB. Switch to advanced. Let's see, switch to advanced. So data events. So go into S3, then log that, enter name. Let's go next. We'll come back and check that. Aggregated events. Those are new ones. Sometimes they change all stuff. So I come here and create a trail, and then basically, okay. So now I set up basically a trail. Now I know I can track every single event for S3. Now the good thing is that now if you open this specific one, data you start the way that you see logging is done. So you can stop or start logging. So one of the great things about this is that now we are good. So what happens is, if I wanted to track something, so I've used this a lot with clients. When a client is probably one of the environment, they have an environment where they have deployments that are failing. They're trying to figure out what exactly is the problem, because most enterprise use cases use AWS organizations where they have a specific account that is routing traffic through God knows how many, how do you call it? You just have one specific account that basically routes traffic. So they are trying to do permissions, and they're not sure why these deployments are failing with S3 permissions. So we had to come and set up S3 CloudTrail. Like I said, CloudTrail, you set it up because you want to get the results immediately. If you can't do that with server access logging. And after that, we made a request. You get, so this is the requester. Then you go to the requester to the other account and figure out, okay, so this is the permission. This is where we need to update all our permissions. So now if you go here, for example, if you go to the trail log location in this case, if you go back to trail log location in this particular case, you'll see, go to CloudTrail. So right now, it looks like nothing has happened. So how about we can upload objects to this can upload objects to this bucket, right? So far we don't have logs. So let me look at logs. So CloudTrail. You can see UST1 2026 object, basically data is already coming in. So it's already logging. We already have we already even have one JSON file here. Now, we used to have a good idea of query with the three select. S3 select used to be a great. I don't know why they basically sunset it, but it was a great. You could basically query a single object. You could query a single object here, for example. So like GZ, you can actually download the GZ file here, for example, and then open it. So this is a JSON. So you can see this is an event. So this is an event. So it has a specific events. You can look at all this. So the thing about CloudTrail, like I said, it's instantaneous. So I set it up right now. I can run a specific experiment and then query that specific server in a while. So it's the same thing. I simply go to, in this particular case, where is Athena? So I simply open Athena and I can set up my table I can set up tables for my specific, in this particular case. So come here, basically, so look at this. One of the great things is, for example, in this trail, in this particular trail, for example, so if I come to CloudTrail and then I go here to, let's look at events. So event history. So I can simply do that. So I can create an Athena table. See, I can create an Athena table. It's done automatically for you. You can also do it the same way I did the other one. So you can see it creates all this. And then you choose a bucket where the CloudTrail. So this is the bucket where we send all those specific ones. Then once I create a table here, bam. So once I create a table here, I can simply go here. And you can see I will create, so catalog, right? And then access DB, so default. So if I go to default, you can see we have a table that is called CloudTrail, right? So if I preview this specific table right now, we already have 9 requests. Yeah, so you see 9 requests, and if you come here, if you look at the timestamp, you can see that these are happening. You can see where the timestamp, timestamp. I'm looking at timestamp. Okay. Probably source IP address, error message, request parameters. Additional event ID, resources, API call, okay. TLS, let's look at that. So event time. So it's supposed to be event time. So that comes after user identity. So if you look at user identity and then come here, yeah, event time. You can see this is happening at 0140. So 2020 1401. I'm not sure what time. I'm in UTC plus 3. What time is it? It's 5. 5 minus 3 is what? 5 minus 3 is 2, yeah? Yeah, so this is using, we're using UTC time. That's why it's 14. So right now it's 17, right? 17 minus 3, that basically gives us 14. So this is using UTC time. So I would have to correct those to UTC plus 3, but you can see this is happening here, right? So one of the biggest advantage about disadvantages you can see from CloudTrail is that unlike server access logs in this particular case, right? Server access logs actually give you URI. So for example, if I did put an object, it actually gives me the URI on. I can actually notice that, oh, okay, this is the object I did. This is the request key. So you see we have a key here. That is the one thing. If you go to, for example, in specifically, you will not see that specific one on CloudTrail. So CloudTrail will not tell you what specific key was that was sent, right? So if you look at through this, all of it, you're not going to see any key. You will not see any key from here. So that's one of the things you should also know, whether you're going to choose to use CloudTrail events or you're going to use CloudTrail data events or you're going to use server access logs. Key, you do not get a key. You don't get a key. If you want to know your key, you'd have to, using CloudTrail, you'd have to check your request ID, then send that to AWS support so that they figure it out. So those are one of the specific things that you can see. So you can see this one is instantaneous. Data comes in specifically, right? And then also, if you're going to, the differences is on CloudTrail server access logs, for example, you can see we call this operation. So operation is rest.put. We use rest, and those are capital letters. When you come to CloudTrail, for example, you call it event name, event time, right? So for example, if I wanted to run, so select from default, let me remove a limit and say, so let me just basically limit where, for example, event name, right? Equals is equals to, in this particular case, so that was REST. So in this particular case, rest.put.object here, use put object. That is a request. Let's see if there's any put object request between now. So we can see we had 4. And you can see the requests are because it's a CloudTrail. So these are the requests are coming from the fact that we are basically logging the entire S3 buckets, and some requests basically went to CloudTrail. Yeah, so they were uploaded. But obviously, you will not know. You see, so basically Athena. So the requests are happening on Athena and CloudTrail. So the user agent is CloudTrail, is making put request to a specific bucket. So the bucket name, obviously, you're going to get. So this is the Athena results. Specifically here, the key, not so much, right? Not so much. Also, one of the better things is encryption. You see, I can actually see which encryption. For example, I know this is AES 256. I know that we are using the default S3 server-side encryption. Yeah. So I can also look at this. I can also see this from CloudTrail. CloudTrail will basically tell me, okay, this object, what exactly, how is it encrypted? What key have I encrypted it with? It basically, those will usually show up on S3, on CloudTrail. Yeah, so they all serve the different purpose. Also, for example, CloudTrail has extra features. For example, basically, logging is very key. You want to have a specific electronic data trail for whatever goes on in your account. That's why, for example, what we're doing here is basically probably basic, because when it comes to accounts that basically do logs, we set up landing zones. Usually, you set up landing zones using what service is this? The specific landing zones that you set up, then especially the log buckets cannot be changed. They cannot be changed. You cannot do anything to those. Log buckets, the only person who can touch those are the specific management account for where the landing zones are set up. And you have to assume a specific, so you don't get, obviously this is some sort of crude method that we're basically using to show. But when you come to real enterprise use case, we don't even do things like that. We have landing zones that are set and say, these specific buckets are going to be for logging. No one can touch them apart from this specific account, this specific role, and then I have to assume that role. I have to actually assume that role before I can do any changes to this specific thing. So you use that for tracking data. So pretty much they work. So you simply just write any SQL code. Basically, for example, if you want to make sure, if you want to look for requests that came in through a VPC endpoint, they are all here. Yeah, read-only requests, TLS details, for example, we have TLS details. So TLS details, for example, you are looking for a handshake, for example, you're running some sort of legacy you're running some sort of legacy things, applications that are running, I don't know, Java SDK version 1, which was basically already deprecated in 2025, December, and you're getting specific issues. You can look at TLS details for if you're getting any issues. So this is just, what is your imagination? How much can you imagine? Yeah, how much can you imagine? So that's probably done for server side. And this is some very just stuff that is up here. If we wanted to go like super deep dive, we'd probably take like 5 hours sitting here just going deep diving. So what I'm saying is this is supposed to just help you know what you need to do and where you need to go to even dive deeper, right? And this is simply we're doing server side. So it's okay, it's server side because it's S3 that logs it for us. The difference, if you want to set up logging using CloudTrail, data events, that is going to be very expensive, especially for people that are, imagine probably like Netflix or something. If they did a CloudTrail data events, your bill would spike out of control. It would literally, this has bankrupted people. So CloudTrail data events are used for specific things. Like, for example, you're sitting down, you're trying to debug an issue in real time right now. Set it up, look at it, get your logs, query them quickly, and then stop logging. Otherwise, in fact, I should stop logging mine. Where is mine? Where is mine? I should go stop logging my own. You have to cut costs. Where's my log? Let me see, CloudTrail. Yeah. You should only ever use them. You should only ever use them when they're necessary, right? So that is materials. Let me go to materials. Let me come here and stop logging, man. I should stop logging so I can stop. Yeah, in fact, I want to delete. Yeah, okay, that's okay. That's okay. So I can stop logging. There's also some of the things that CloudTrail does is log validation. You have to make sure that the logs that you have are not tampered with. Somebody might decide to, for example, if somebody is trying to cover their tracks about what happened, somebody might try to delete the logs, or some might try to tamper with specific logs. CloudTrail has log validation where they make sure that you're signing your logs so that when you come to check your log, the logs are what they are really supposed to be. Yeah. So we also have log validation for this, which server access log doesn't have. Also, the good thing about CloudTrail is that you can actually do cross-account logging. So I can log everything from this account. So I can have a central buckets, and then I can log everything else to that bucket. When you're doing server access logging, all logs must be stored in the same account as the bucket, as that specific bucket. So if I'm logging this bucket, server access logs can only sit in that specific, in buckets that are in that specific account. So those are basically things when it comes to specifically logging. Now, the next thing I want to talk about is what we call, let's talk about what do you call it? This storage lens. People don't know about it much, but man, does it. The amount of issues that you basically solve with this, especially when it comes to cost, it's mad. It's mad that people don't even know about storage lens. It's especially so. This is a storage lens dashboard. This is the basic. You can actually come up with your own custom version. You can create your own. Obviously, it's going to cost you a lot, but storage lens metrics gives you so many. So right now I have 174 megabytes worth of data, 11K objects across all my buckets. So it tells you all of our active buckets across one account. Yeah, tells you total storage, average object size, and stuff like that. Let's figure out some of the things that you would actually use for cost. I've actually done. So for example, in this case, top end view for this. So let me do, for example, I have the first, this should go up to 25. So I want to look for top 10 buckets. Then we have metrics here. So one of the things when you want to do cost optimization. Now, one of the things about S3 is that when you're talking about performance for S3, there are things that S3 does to optimize performance. And one of these is basically what you call multi-path uploads. So when I upload an object that is 100 megabytes, S3 basically says, instead of overloading a single connection, TCP connection with that, we're going to split it across S3 endpoints, right? And then say, okay, now you're going to send all of them, we're going to send all those requests to S3. So let me see. All right. So like we said, they just all make sense. So okay, so a dig s3 dot amazon aws.com, right? Right. So you see we have this. So you see we get 8. We get a multi-value answer, DNS answer. You get that. So all the time, so S3 by default will set that up. It will do that. So once it sets that up, every request basically sends to S3. So if it's 100, let's say 20 megabytes, five connections, and then once they get to S3, they're reassembled and then they sit there. It's much better than sending, let's say, for example, a 1 gigabyte object. You send that 1 gigabyte over one TCP connection. What happens if there's a problem with that connection? It drops. You're basically ending up with, you have to, your client, obviously, depending on how you set up your client would have to reinitiate that specific connection so that you start that. And then you do the entire thing. It's not a very efficient way of doing things. So one of the things you do is by default, if you're using any SDK, any AWS SDK basically implements this because they have CRT runtime framework, CRT runtime basically below them. So they all implement this. So basically, when you send all these objects, for example, if you're uploading a 1 gigabyte object and it decides to send 100 megabytes over 10 connections. Now, if something happens where you get interrupted and your connection is completely lost from your client, these objects, you will not see them in your bucket, right? Even though, let's say chunk 1, chunk 2, chunk 3, those already sent to S3. And then you probably had chunk 5, which was not sent. And then obviously, if you look at initiate, upload, initiate, so create multipath. If you look at the create multipath API, so create multipath API, create multipath upload API. So if you look at this specific API, create multipath upload API. So create multi-path upload API basically is that create multi-path. So end of support as discontinued support. Okay, that's okay. So this action initiate a multi-path uploads and return an upload ID. So it initiates it, then generates an upload ID. The upload ID is used to associate all the parts in a specific multipath. So we generate upload ID, and then we say we have this specific amount of parts. Yes, so they're attached. So you send each part with the upload ID attached, and we know that we're expecting 100. We're expecting 100. Probably we're expecting 100 parts and stuff like that. So when they get to the other end, then those are matched together to form a specific object. When you get an issue where your client basically fails and it can't send anything anymore, you end up with objects in S3 bucket that have not been they haven't been attached together, so you can't see them. So since they have not been, we have not done. So we create multipath upload, and then once you're done with create multipath, then so there's what is create multipath. So create multipath uploads. So we start with the create multipath, and then sometimes I get create multipath upload. Multipath upload. Let me look at which multipath upload. Let me look at that API. I kind of forgot. So uploading object using multipath upload. So we do multipath upload process. Yes, complete. So when you open the complete multipath. So if complete multipath upload API has not been called, you will not see those objects in your S3 bucket, right? You will not see. So the only way to make sure those objects don't stay there indefinitely is if something went wrong with your client either needs to call the abort upload multipath upload API to clear those, or you need to set up something like storage lens. So if you go back to storage lens in this particular case, storage lens. So here, I come in here and then I want to look at cost optimization. So I come here and look at delete markers. So I want to look at let me see cost optimization and current delete marker, incomplete multipath upload bytes. So I come here and look at incomplete multipath upload. So look at your object. So I've had clients who had about 100 terabytes worth of incomplete multipath uploads. Now note, you will not see these objects. You're still going to get charged for storing them, even though they don't exist. And most of the time, since you're in a high performance environment, these things fail a lot. You end up with 100 terabytes that you're paying for every single month for objects that you're not using specifically. Yeah. So you're not using these objects, and you start wondering, S3 is giving me this amount, this cost for these objects. I only have about 2 terabytes of data. Why am I getting charged for 10 terabytes worth of data? That is when you come this specific here. So right now you can see I have 0 bytes of incomplete multipath uploads because I know about it. So if you're here and you have an account, just go down there to storage lens and check this to incomplete multipath. You check if do you have any. If you open any AWS account, if anybody has that open, can you check if you have any of incomplete multipath upload bytes? Because you're getting charged for those, even though you have never seen them and you're actually using them. We do that. So that's why, for example, if you open some of the things about if you have an S3 bucket, for example, like this, things like in management, you need to have a lifecycle by default. The things that you need to have at this point, when you create, you need to have a lifecycle rule that basically delete expired object, delete markers, or incomplete multipath uploads. See, this should be there. So you say after every 1 day, anything that is not uploaded and deleted, I should come here. Let me say multipath. So I do multipath. So by default, you should always make sure you have that. Okay, so prefix. So apply to all objects in this particular bucket. So this. So you create a rule. You should always have that. That way, you don't have to worry about anything accumulating and you having to run with those. So those are storage lens metrics. That is incomplete multipath uploads. Another one is non-current version bytes. So if you're running objects, you're updating objects. There are specific versioned objects and unversioned objects. So you might end up with, for example, you have specific spreadsheets that you're actually updating, right? So you keep on updating a specific spreadsheet all the time. So you end up, you have 100 versions. You only see, because, when you open a specific S3, for example, you look at here, when you make a request, for example, you do a head object request to S3 for using a specific key. S3 only returns the most current version of that specific object, unless you specifically specify the upload ID, the version ID of that object. So if you come here, for example, bucket metrics, look at this. come here. So if I open this, I open this, I open this. So right now I'm here, for example. So if I basically let me see, get. So if I want to do, if I do a get object request to this, just using the key itself, right? Get object, or let me see, head object. So let me see, AWS CLI head object. Object. Let me see. Let's see, head object. So we're returning that. So head object bucket value, and then if match, obviously key value. So okay, so that is AWS S3. So let's open that. So AWS STS. Okay, so I haven't done that. So give me a second. Let me just copy this. Just copy this. And why that is pasting, I can do that. Clear. Get caller identity. What I think I just did that. Did I just export this? When calling get caller identity. Let's see. That's something. Let's do that again. Get credentials. All right. Identity, right? All right, so we are good with that. So now if I come here to, for example, if we do a specific object, for example, this is our key. So we're looking at that specific key. So so AWS S3 API. So we're going to use our low-level S3 API. We're going to use S3 API operation. So let me just do this. So that happens like that. So we're going to just use AWS S3 API. So we're going to do a head object. So let's head object. So we do object, and then what do we do? So we do bucket, right? So we do -- bucket. So in this particular case, we're looking for this specific bucket. This is the bucket that we are heading. And we're only going to pass this specific one. So we're going to pass the key. So we're going to pass the key and the value. So -- key key bucket goes to that, and then key, we're going to pass the key, which is in this case is specific. This is the key. So we're going to pass this specific key. So it should return a 200. Right, so we get a 200, okay, which is this specific one, right? So this is, by default, we've simply passed the key. However, if you look at this objects and version, when you have versions of objects, we use version ID. So there's a part where you now pass a version ID, yeah? So you actually pass a version ID. So there are specific versions of objects that you actually have. So if you just pass the key, you get the current version. If I did have a different like 100 versions, I can get all these specific objects. So you might have like 10 different versions of an object, and they're cutting up space. And because you do not have because you do not see them, you realize, for example, in this particular case of mine, I have 50 out of 140. 50 of them are basically non-current versions. So I also need to set up a lifecycle policy to make sure any non-current versions of objects, I delete them. So if I only want two versions of my object, then I can come and set them up and say, okay, I'm going to do a lifecycle policy that basically makes sure I only keep the two most recent versions of my object, and then that sits down. Yeah, basically. So those are the things storage lengths, and it does so much more. For example, delete marker. Yeah. Do you guys know what a delete marker is? So I'm going to walk you through one of the things, and I'm going to talk to you about. There's a few weird things about S3 being an object, which is weird. So for example, if I have an object like this, for example, if I go to, let's say, if I go to this 15L, right? So this 15L. And then I decide to delete an object. So AWS S3 RM. So RM is removed, right? So make bucket. We have RM, I believe. Sometimes the high level API, sometimes I get. So let's do S3. Let's do S3, for example. This is copy. Let's do this is, for example, this is and then I say 1, 2, 3. See, weird. One of the things you should know is that when you send a delete request to S3 for an object that doesn't exist, it actually doesn't throw you an error. It's going to successfully send you a 200 request. Okay, yeah. And even if you debug that, it's going to send a successful request. Thread pool 200. Okay, you can actually grep that, and you're going to find it's actually sending you a 200 request. Now, if I come here and basically do this, upload, it's not going to show. Now, if I show versions, see now, I got a delete marker. So I sent an object, I deleted an object that didn't exist, and I still got a delete marker. So a delete marker is how we protect objects when you version an object. So that if I come here and I say, come and delete an object like this. So strace. So for example, if I come strace object, obviously when I delete the object, for any object that is versioned, we are basically doing soft delete. So we're basically saying, don't look at this. So I delete that object. So right now I've actually deleted that strace. It doesn't exist. But if I show versions, you can see that what happens. This version ID, this one. So this object that was current, it became non-current. And then a delete marker basically came up, became the most current version of the object, right? So this happens a lot, especially sometimes when you want to do recovery, you want to write code, basically. So you had an error where some code was running and then they deleted all other objects. So if it's versioned, basically makes sure that just those objects are basically self-deleted. So in order to restore them, all you had to do is just run through, list all those objects, and then to restore an object, you need to delete the delete marker like this. So you delete your delete marker. So permanently delete. So when you permanently delete your delete marker, you basically get your object back, which is that. Yeah. So you also that. So delete markers, you can say, because one of the things people know, delete markers sometimes they also you might have so many delete markers they get to gigabyte level. This is something that I've seen. They're normal in production environment. So you also want to make you also want to make those lifecycle policies which have delete markers to delete. Now, delete markers, if you check, for example, if you look for delete markers are actually 0-byte objects. Yeah. So for example, if I delete this, for example, this is a test.pk. So these 385 bytes. Now, if I delete an object, for example, let's say permanently delete. Somebody might ask, okay, if delete markers are 0 bytes, for example, if I come here and then I show this, okay, so show this. I don't know. Oh, I deleted the object fully because the show versions was on. So in the console, if you enable show version and then you delete an object, that is the same as sending a delete request with its version ID. So sorry about that. So I deleted that without knowing. I don't think it's an important object anyway. So I'm going just to delete. So I'm going to delete. So if I delete that object, obviously close. And then if I show version, you can see. So delete markers are 0-byte objects. However, people don't realize that even though it's a 0-byte objects, we still need to store data. We still need to store metadata about that object, which actually costs a certain amount of space. So you should also need to know that. So those are things we're going to talk about. Storage lengths. It has so much, so you can basically group things depending on prefix. So if you are looking for a specific prefix that you can aggregate across specific prefix, especially when you create your own custom dashboard. You aggregate across a prefix, specific buckets, it gives you across buckets over the last day, over across what bucket. You want to look at which storage classes do I have that, for example, if you're doing lifecycle transitions to specific buckets, you want to look at which storage classes most of your objects are. You can see I have in standard. It gives you a dashboard of everything. Total storage, active buckets, you can use it to check which objects are active. For example, having buckets in your account that are not being used is a security risk. So you can check which buckets have not been used, and you can retire those specific buckets. It's something that happens, right? So that is just storage length. Storage length gives you so much that you can work with, which is basically done. Now, from there, I think how long was this supposed to be? It's already 5:30. Let me finish up in the next 10 minutes. So those are basically, we were doing server-side logging. Now, client-side logging, now that basically just depends from how you're working with. It depends on which SDK that you're coming with. So for example, if it comes to here, for example, so if you're going to do logging client-side, right now my client is. So if you're making any request, so I want to log and I want to figure out what is exactly going on. So I'm using S3 RAM, and then I'd say debug. So when you add a debug flag, you basically get every single information. You get every single information that you need from S3. So you're basically logging. So for example, I did that here. Then a few of the things that you can check here. So AWS CLI is basically Python. So you can see I sent a delete. You can see I sent delete here. Then it was sent here. It was sent to this 151L and then 123. Then you can see calculating signature using version 4, right? So I'm calculating signature. We talked about signature earlier. So signature version 4, and then we're making a canonical request. So you can see, for example, depending on whether you're using, how are we authenticating? I believe what we're using here is auth headers. And you can see that our host is this specific bucket here. And then content is calculated using SHA. And then we pass our date as well, our security tokens. So this is our entire specific token. Yeah, you can see we are passing our token. So AWS signature version 4 HMAC, this shows. And then you can see region, we also pass our region specifically here. And then we are supposed to look at where is the signature. I'm looking for where we get our signature. So there is where we attach our signature so that when the request gets to S3, S3 calculates that signature, and then basically it uses hosted. What's ES security token? So this is a security. No, that is the security token. I'm looking for the signature. I'm looking for the signature, AWS request. So S4 request. So signing. This looks like it. So 2026 USC signature version 4 request. So this is the signature that was calculated here. So when this does get to S3, let me see debug signature. So let me see debug equals signature. This is the signature that we get. So when it gets to S3, S3 is going to use these specific headers, strip them off, and then use it to calculate its own signature. And then these two are supposed to basically match. So this is how you basically get to calculate things. So I believe if you look through this enough, you can look for example, these are the XMZ ID2 and then response headers. They're all sitting here. You can get request ID, they're all here. So this is you're debugging your client. You're debugging your client using, for example, in this particular case. So for example, you can look even credentials. So when I look at ASIA, that means I'm using short-term credentials when you use SA. Anything that is SAIA means I'm using a role, short-term credential. When you see AKIA, it means you're actually using long-term credentials where you're using access keys. You're using an access key and secret keys. Those are there. So this is basically only at the, if I'm using the AWS CLI. Obviously, when I'm using a specific SDK, for example, logging, using Java SDK version 2. So whether you're going to use Godot 3 SDK, I'm talking about the one that I'm actually more familiar with. For example, this is how you would configure your specific logging. I actually did set up, for example, let me see, CD SDK. I did set up a current one, and then I went to CD into Java. Less, I think I CD'd into TCP reset connection. So if I do history, let me see. History. So okay, I can do this specific one. So I was basically simulating this. So I basically set up Java. So if I run Java connection, don't worry. So basically what is happening here is I have set up a client, which is basically sending a request to S3. In this particular case, we are basically simulating things like TCP connection drop, timeout errors, socket connection errors, and stuff like that. And then we are going to, when we are done with this, we're basically logging it. So if I come here, CD into SDK, and then Java, I believe, Java, and then CD TCP. And then, yeah, so I have this one called S3 wire log backup. So if I do less S3 wire, okay, I'm S3 wire log, yes. So I basically, in this particular case, what I'm doing, I was doing what you call wire logging. Now, wire logging is one of those kind of logging that is probably you should never have wired logging on production database, because the kind of hit you're going to get on your performance is actually very bad. Yeah. So these are basically things that you enable them at last moment, because you have no other way to get issues while you're getting. So wired logging basically gives you a logging of every single issue that is happening, everything. It gives you wired logging. So if you look at something like Java 2 SDK, it basically uses log4j configuration files for basically logging. Now, a few logins are, you have a simple request response summary logging, which should just basically give you simple, what are your request ID, HTTP status, and stuff like that. Then you have debug level SDK, just a little bit. It's probably just a bit higher. And then we have wire logging. So wire logging is basically when things are getting really serious and you need as much information as you can from your client. So these are basically client. So if you're using Go SDK, if you're using C++, they're going to provide different ways that you can basically log response and then figure out, what exactly is going on in this particular scenario. So that is probably, how we would do logging client side, depending on whether both or three and everything. So one of the things I say always, these things, how do you call it? Documentation, very well done. If there's one thing I'll give AWS props for, is that the documentation is top notch. Most of 96% of the time, you realize that the issue just needs you to do a little bit more of documentation deep dive. Then a few things, for example, obviously, when you get specific edge cases, that's when you need to contact AWS, especially for issues like, for example, we have a regional outage and stuff like that. That's how it works. So I think that's as far as we can go. We can't go deep dive enough out of this. I hope that should have pointed you in the right direction. Otherwise, thank you guys for having me.
Right. Thank you, Kefa. I think this was really, really comprehensive. I was actually following along at some point, trying to create my own Athena and querying. Moved a bit too fast, but I think it was really comprehensive. And I think biggest takeaway, if you can, once I've finished I've uploaded the video on YouTube, you can go through it and just understand more about logging and just S3 and how it works. And specifically storage lengths, I think is really, really good. I think there was one question here. Okay, Mike had asked, have you ever used AWS S3 files in your processes? I think we'll do like another 5 minutes, then we'll leave. I also had a few questions, but I think because of time also it would be good. Yeah, you can answer that question, then we can go to a few announcements. Then yeah.
So if I ever use S3 files in a few of my projects, not really. Okay, so one of the perks, one of the things you realize S3 file basically solves is S3 files solve a lot of enterprise issues. So for me to set up S3 file at a level that I feel I can actually make use of it, I'm going to have to use a lot of credits. I don't have that kind of amount. One of the things about working for AWS is you can use 10,000 USD per month. Nobody cares. When you leave, you can't do that anymore. So S3 files came after I left, so that's a bummer. But yeah, I haven't set it up. So so there's things about S3 files because there's a gray area because we already have things like S3 Fuse, open source. We already have mount point for S3 was already sitting there and stuff like that. But yeah, not yet.
There's also a question here by Gilbert Winger. Athena in comparison to other login search indexes like OpenSearch, Elastic. Do you mind asking your question? I'm not quite sure, or I don't think I understood it, Gilbert. Do you want to ask it? You can unmute and ask the question, or Kefa, if you understood it, maybe.
So Athena in comparison to other search indexes like OpenSearch, Elasticsearch for S3. Well, I understand what they're saying. The reason I use Athena because Athena and S3 are this tight. Yeah. The integration is very good. So one of the things I usually do is first principles. I don't need to use a specific service if I don't need to use it. So Athena already does everything. It does it really fast and it integrates really well with it. So I use Athena. So I don't need, plus, Elasticsearch and stuff like that. I'm not storage. So Elasticsearch basically extends beyond that. Athena already does, the engine already does everything that I needed to do for my so it works for me.
Okay, great. Last question actually from me. I'd seen next to query results, you can save some of the queries and also query stats. It shows you like total runtime in milliseconds. Maybe we can just go through that. That was kind of interesting.
Okay.
See. Yeah. Do that and then just call it a day. That was interesting to me. And once I've created, because I've already created an like the database and all that stuff, can I destroy it, or does it? What's the cost implication so that I know?
No. The cost of keeping the database is very minimal. It's like it's not even going to show up. So the way Athena works is you get queried for how much data is scanned. You see this? See?
Yeah.
This is data scanned. Oh, sorry. My bad. Confirm you can see my screen.
Yeah.
Yeah, so the way Athena works is Athena basically you're charged for the data that you scanned, right? And one of the good things is that if you set up your Athena query to have partitioned data, then it means that every single time that you do search, you're going to be searching basically 4.244 KB, small data. So it's basically insignificant. The only problem is if you have 10 gigabytes worth of data and you did not partition your data, you're going to end up scanning about 10 gigabytes, 100 gigabytes, depending on how much logs are coming into your bucket. Then you end up with a big bill. Yeah. So one of the things we usually also do, for example, depending on how company policy works, company can say that we are only supposed to keep logs for, let's say, up to 1 month or 7 days. So you can set up a lifecycle policy on your logging bucket that says after 7 days, basically make sure any object that is past 7 days, we basically transition it and then delete all of it. Yeah, so you only charge for 42. So you can simply destroy the database. So you can simply come here and then destroy the database and stuff like that and go to the bucket and delete it. But one of the things I figured is once you set up something like a database like this, you don't need to destroy it because it just does a lot. It just does a lot for you. It does a lot. So if for example, your account has a lot of data, just say, okay, you can do 2-3 days, just so that all the objects that are older than 3 days can be transitioned out, so that you will end up with that entire cost doesn't even make it to $1. It doesn't even make $1. It doesn't make $1 actually. It's very limited. Yeah. So you should be good. You don't need to destroy it. Somebody's asking again. Eh?
Yeah.
So the same concept applies as S3 vectors as well as observability and logging that you demonstrated. Yes, S3 logging, yes. So they do the same exact. So if you go to S3 vectors, So S3 tables. So for example, S3 tables. S3 tables also has the way to log it. So if you create a bucket, you can also basically log that bucket to S3. It basically uses the same exact concept. The only difference is that we already were talking about Apache Iceberg on S3. It was happening. Customers already were using Apache Iceberg. In fact, it's something I can even set it up right now. Except the only difference S3 did was, okay, S3 is already, it's the most, it's like 20% of the internet. It's the most durable, it's the most dependable. What can we do? What can we solve for the customer? Is let's basically build our own proprietary on top, and then we're going to say things like maintenance. We're going to take maintenance away from the customer because, S3 maintenance, table maintenance thing. The customers that were running them on S3 bare had to basically spin up some sort of, Apache Spark or on some, how do you call it? EMR. They have to spin up EMR so that they can run their own maintenance jobs. AWS basically says, no, you know what? We're simply going to do that on your behalf so that you don't have to think about it. All you have to do is manage your tables. So you simply set rules and say, this is how I want to do compaction and table maintenance. This is how I want to do all this transition. And then your work is just focus on analyzing and querying data and don't think about all that stuff. Yeah. Yeah. So obviously including the backend. So as Apache version 2, version 3, you come to probably version 3. You don't have to worry about all that because you have an open S3 sits there. It's already cheap. S3 is cheap storage. Yeah. And then you have AWS basically running more stuff for you. Yeah. So it's the same concept. Yeah.
Yeah, awesome. Thank you. Thank you. Thank you, Brian. I think this was really, really good and quite comprehensive. Yeah, so thank you guys for making time. And I know we passed by 30 minutes or so, but thank you very much for making time. Just a few announcements. Can I can share my screen if you don't mind.
Yeah. Sure.
Let me see. A few announcements. So one, this will be recorded, then it will be uploaded on YouTube probably maybe tomorrow. Let's just do tomorrow. I think that would be good. A few things. One, so that we'll just go fast. There's the AWS Community Day coming up. Oh, let me see this one. Yes, it's coming up on 4th July actually. So it's like nearly about a few minutes coming up. It will be in Mombasa at Swahili Port Hub. Let me see. Swahili Port Hub. Swahili Port Hub. I'll tell you for maps. Yes, it will be in Mombasa, Old Town, I think. I'm trying to see where it is, but it'll be at Swahili Port Hub on the 4th of June. So if you can do grab your tickets. There is also, I think, speaker unveiling soon also. So yeah, if you're planning to go, you can reach out also, figure out logistics going there. So you can still get tickets. There's one for 300, 350, and one for 500. So there's that. Any other thing I wanted to mention? There's also there's a game day coming up, but that one's still in the works, so it's not yet ready. There's something else I was gonna say. I've forgotten. I think the she builds. I've forgotten the other thing that I was gonna say. But congratulations to the community builders who came back in, and also the community student builders group. Also, congratulations to them. The last thing I was going to mention, I've kind of forgotten. I'll probably just post in the group. Yeah, I think that's pretty much it. Thank you very much, Kefa, for just making time, and for everyone else being here today. And yeah, this was really good. I think I've really now come to appreciate how S3 is used on an enterprise level, and I think we should have Kefa do more workshops essentially in terms of this and walk through it. Yeah, thank you very much.
Yeah. Cheers, guys.
Cheers, guys. Have a good one, guys. Bye. I'll stop recording.